My topic for the day would revolve around Waku Protocol and how we are uncompromising Web3 communication at scale. So what is Waku? Waku is a family of private, secure, and decentralized communications protocols. So essentially, we're building a toolkit for Web3 communication, and we are making sure it's useful for building censorship-resistant infrastructure for any kind of use cases when it comes to dApps. So why Waku? We are building something on the lines of censorship resistance. So we are building on the lines of censorship resistance and decentralized messaging between dApps and different nodes in the Web3 network. And we're also building on the lines of privacy preserving stack so that at Status, we are really a company which care about privacy a lot. We are essentially a messenger which cares more about privacy and security on a scale. So we are also securely scalable. We have something called RLN coming up, which is a research project going on by different companies for a long time. So Waku Protocol has done it on production and it's available in our mainnet. And we are also portable and we make sure to cater different bandwidth environments. So it can run on your phone and it can run on your resource restricted environments like dApp node or anything of that sort. So history of Waku. So in 2013, the holy trinity of decentralized web started with Ethereum's white paper. So Ethereum had 3 segments. The first one was Ethereum for consensus, and Swarm for storage, and Whisper for messaging. But right now, at this point, Swarm and Whisper are like very much underrated. People don't know about it, especially the people who came into the space in the last 2 years, because we have more product-centric startups right now who are doing stuff with messaging and storage, like Filecoin for storage and XMTP for messaging. So until 2019, it was very slow it was a very slow progress with Whisper, and there were not much of dedicated teams building on top of Whisper. So right now, Whisper is Waku Protocol. We've transitioned in terms of scalability, performance, and Whisper is Waku at this point. So in 2020, Waku V1 replaced Whisper in the Status app. So Status app has more than 500K downloads in Play Store, and it's one of the most used Web3 apps at this point. So with Whisper V1, we were able to provide enhanced performance, better scalability, and also ability to work in low bandwidth environments like your mobile phone. So it's easier to run a Waku node in a resource environment which can cater a lot of people, just like your laptops and stuff, but it's harder to do it in mobile phones. But Waku V1 was able to do it. And we also ensured low data consumption and low resource utilization with Waku V1. In 2021, we released 2 SDKs, JS Waku and Go Waku. And right now, Waku has evolved into a standard for Web3 messaging. And we are trying to onboard as much as companies who are on the lines of communications. So Waku is actually a public good infra project. So it's open source. Anyone can pretty much fork it from GitHub, and you can run your own Waku fleet on your own. So it's also CC0 license. So there's no liability, but you can just fork it and use it on your own. We also have RFCs at this specific QR code, which has more than 2 years of hard work from the Waku team and Status team. So you can find the RFCs if you're interested. And now I'm going to outline getting started with Waku. So you have 2 ways of getting started with Waku. You should identify yourself as a node operator or a developer who builds on top of Waku. So if you're a node operator, node operators contribute to the network by making Waku decentralized and secure. So we have multiple types of nodes. We have relay nodes, which are more powerful, and we have light nodes, which run on mobile phones and resource-restricted environments. You can run it on your VPS, home server, or pretty much anything that can run a command line. So it's permissionless, and we don't have any sorts of incentivization within the network. So you can use it on your own terms. And also we have predictable resource consumption, and DOS protection is on the way. So right now, to be honest, anyone can spam the network and anyone can turn the network down. But that's where we have RLN coming up, and the DOS protection is work in progress. But we are looking to complete it in the next 2 months. You can build on top of Waku using our following SDKs. We have JS Waku if you're interested with JavaScript and TypeScript. We have Go Waku, N Waku, which uses a language called NIM. And we also have Rust bindings if you want to use Waku in your Rust application. So this is a getting started guide if you want to check out our documentation and stuff. And to create a Waku app, it's very easy. You can just run yarn create at Waku/app. This is like a boilerplate that can help you set up a Waku app real quick. And we also have React hooks, which can help you ship out Next.js apps or React apps with much ease. And we also have core SDK at Waku/SDK. So all these SDKs are battle tested. We have it running in production. We have a couple of companies like XMTP using it already on a scale. So the following is a layout for a basic Waku message. So we have a Waku message object with a payload number. And we also have something called content topic, which is very much similar to pub sub topic. And we have a version ID for each and every message, a timestamp, and also some metadata linked with it. So this is the whole layout of a Waku message. So content topics are very much similar to pub sub topics. So I always say that libp2p is the holy grail of Web3, but most of us, we are not aware about it. We just talk about L1s, L2s and all these things, but we have such amazing tech which was founded like probably 5 years ago, but we're not really using it up to its potential. So we are following the same mechanism as libp2p. So we have pub sub topics for routing and content topics for content-based filtering. So if you want to build on top of Waku, you can make your own content topic, and then all your messages go into the content topic, and you can just filter out these messages from the network. And RLN is basically a spam protection layer, which works based on reputation, and it's state-of-art P2P spam protection. We just wanted to make sure we are not compromising decentralization, just to make sure it works on a scale. So it's completely decentralized, and yeah, it's currently work in progress. So we are trying to ship it out by the end of Q4 this year. So we have multiple Waku protocols. The first one is relay. So it is peer-to-peer gossiping between multiple nodes in the network. So if you have a node running on your laptop and there's another laptop, they both are relay nodes. So it's the backbone of the network, and they provide more availability to the network, resource availability. And we also have light push and filter, which are meant for resources that are low, for example, your mobile phones. So it just connects you to the nearest relayer, and then it stores the messages on the network. We also have store, which is like a native storage for storing your messages. It is designed mostly for offline devices. So if you are looking to build something for people who are in places where there's less or no internet, you can make use of the store protocol. And we also facilitate end-to-end encryption. We have some E2E libraries integrated into our SDKs already, but then we are also coming up with more encryption standards within our SDK. And the main point is we want to be as flexible as we can with encryption. So you can choose to use your own encryption standard as well if you want to do that. So I'll also run you through some quick examples. So this is a demonstration of a chat app built with Waku. You can pretty much send a message into the network with any ID. So this ID can be your wallet address or any unique ID. So for this example, we use store for storing the messages, and light push for pushing the messages into the Waku network, filter for getting the messages from the content topic. And we also use DNS discovery and peer exchange for miscellaneous stuff. And the example 2 is where you connect a wallet first, and then after connecting it, you generate a key pair, a public key pair, and you broadcast it. And then you'll be able to send messages between multiple Ethereum addresses. So this is a great example if you want to integrate something like wallet-to-wallet messaging. So this is something that can be helpful for you. So you have different use cases to build on top of Waku. Like you have dApp to wallet communication, just like how Wallet Connects guys have been doing it for a long time. So you can make dApp to wallet communication possible. You can build NFT marketplaces where the NFT transactions are not visible to the public. And we also have options to build generalized marketplaces, state channels, game mechanics communication, and also layer 2 coordination. So you can decentralize your sequencers if you're building something with ZK. And also signature exchanges with multi-sig wallets is also possible. And you can encapsulate all of this and make sure it's all private. So right now, these are our 4 big companies who use Waku in their infra. So Status itself, so we have over 500K downloads for the Status app. And Railgun is a privacy layer built on top of Ethereum. And XMTP is like a messaging protocol. And the Graph have also been using us for the past couple of months for various use cases. So right now we are actively hiring across multiple roles. So we are looking for software engineers who are proficient with NIM, Golang, TypeScript. And it's a pretty great company. I've been here for the last 7 months. It's a competitive salary, and then it's a completely remote team. We have more than 200 people working across the globe. So check it out if you're looking for some open roles. And also, please feel free to join our community. We have a Discord server where we have active conversations going on every day. And also follow us in Twitter for announcements about our upcoming events and all the upcoming giveaways and stuff. And the complete code base is open source. We believe in open source, and thus we've made the complete code base open source. So feel free to check out our GitHub. And thank you. I'm open for questions.
Yeah, really awesome and energetic performance by Guru, just like yesterday, if you know what I mean. So, does anyone have any questions? Sure, go ahead.
So you said about wallet-to-wallet messaging system, and you also said that all those messages are end-to-end encrypted. So my question is, where is that encrypted cipher is stored? Is it stored on centralized server, or is it stored on decentralized architectures?
Okay, so storage is not something that comes out of the box with Waku. So you can use the STOPE protocol, but then we definitely recommend you to use something like IPFS or Codex or Swarm for storing this on your own. But then, I can identify store like a caching mechanism, which holds the, very recent messages, not for a long time. So it blends well with other storage services like IPFS. So we want to be as open as possible for such things.
And I also want to know about the latency. So when we use any centralized messaging app, we have a nice latency, right? You just send messages in milliseconds and the other person receives. And I have used many decentralized, messaging systems, and I found that the latency is pretty higher. It takes like more than 2 to 3 seconds even to send a message and then receive one. So what is the latency about Waku?
So honestly, we don't have benchmarks ready right now, but then the usual excuse that we have for this question is as the network grows and scales, the availability of nodes increases, and thus, the latency comes down to a great extent. But then we are working actively on bringing down the latency, but I can assure Waku is giving the best on the grade latency in terms of decentralization, decentralized networks at this point.
Thank you.
Thank you.
Raj?
Yes. So you said like we need to host a node to communicate, right? So right now, how many host nodes are there? So are you like running your own nodes, or like there are some real miners or like the active users who are running their own nodes?
Okay, so at this point, we don't have any incentivization for node operators. So
Understood.
even if you're going to run a node, you're not getting paid for it.
Yes.
But then we have a lot of voluntarily node operators who want to run it on their own. We have more than 100 nodes running at this point right now. And we also have integrations with DApp node. It's like a small device where you can run an Ethereum node or whatever you want, like just a click, and then it runs your own node in DApp node. So we also have such integrations.
So how about the computation? Like,
Okay.
does it require very high computation power to run a node?
Not really, because currently we're trying to experiment with a 4 GB Raspberry Pi.
Oh,
so we were
nice.
able to get a decent output from it. But then the main thing is it works in all kinds of environments, also on your phone. So that's the approach we're trying to go ahead with.
And have you think of tokenomics, like how it will go?
Yeah, we have a separate team doing tokenomics right now.
Okay.
But then the deal is we wanted to be a public good infra rather than a capitalized project.
Correct.
But for the project sustainability,
Yeah, we need a token.
we'll come up with some tokenomics definitely. I'm not sure about it at this point, but the research is actively going on for the last couple of months.
Okay, so like right now, does it support only text, or we can send other files as well, like for chat?
Okay, so we have a 1 MB limit for each message. So
Okay.
you can pretty much put in text, or maybe you can upload something into codecs or IPFS, get the IPFS CID, and then transmit the CID. So that's the approach that we recommend
Understood.
people. Yeah.
Yeah.
Thanks, Raj. So, do we have any other questions in house? Cool then. So, thanks,
Thank you,
Guru,
guys.
for an awesome workshop. See you.